Black holes, huh? I mean, like, mind-blowing, right?
Yeah, they really capture the imagination.
Totally. So mysterious. These massive objects just warping space and time, swallowing anything that gets too close. It's kind of terrifying, but also, like, incredibly fascinating. And guess what? Today, we're diving deep into one that's got scientists all riled up, LID 568.
It's really making us rethink a lot of what we thought we knew about black holes, especially like way back in the early universe.
Exactly. And to guide our deep dive today, we've got some seriously cool stuff data straight from the James Webb Space Telescope and the Chandra X-ray Observatory.
Oh, yeah. And we've also got this cutting-edge research paper in Nature Astronomy.
So we're going all in.
Absolutely.
Okay, so first things first. What makes LID 568 so special? It's not just about how big it is or even how old it is. It's more about what it's, telling us about how these, like, monsters grow.
Yeah, it's kind of like if paleontologists found a T-Rex fossil back when they thought dinosaurs were still, tiny.
Whoa, okay, I see what you mean.
Right. LID 568 formed just 1.5 billion years after the Big Bang.
Which is like nothing in cosmic terms.
Yeah, practically a baby,
Yeah.
Yet it's already a supermassive black hole.
And, I mean, when you say supermassive, you really mean it.
Right.
I know it's called low mass for these types of objects, but...
Oh, yeah, for sure. Even a low-mass supermassive black hole is still, like, millions, maybe even billions of times bigger than our sun.
It's hard to even wrap your head around that.
Totally. But the really crazy part is how fast this thing is growing.
Yeah, tell me about that. It's like way faster than it should be, right?
Way faster. It's like it went on a cosmic growth spurt, blowing past what we call the Eddington limit.
The what limit?
The Eddington limit. It's kind of like a speed limit for black holes, in a way.
A speed limit. Okay, now I'm really intrigued. Explain that one to me.
So it basically describes how fast a black hole can, like, gobble up matter. See, when stuff falls into a black hole, it gets super hot and gives off radiation. And this radiation can actually push back against the black hole's gravity. So the Eddington limit is, like, the balancing point.
Got it. So too much matter, too fast, and things get...
Messy.
Exactly. So how's LID 568 breaking this speed limit? Is that even possible?
That's the question, isn't it? Somehow it's sucking up matter at something like 40 times the Eddington limit. It's totally bonkers.
Yeah, that's not just breaking the speed limit. That's like warping the whole highway.
Exactly. It's making us question a lot of assumptions, not just about how these things grow, but also about what happens to the black hole itself, and maybe even to, like, space and time around it.
Whoa. Okay, hold on, back up a sec. Before we get too deep into that, I gotta know, how did scientists even find LID 568 in the first place? It sounds like it's breaking all the rules.
It was actually hidden in plain sight for a while, masked by dust and gas. It took the combined power of two amazing telescopes to, like, pierce the veil.
Okay, which ones?
The Chandra X-ray Observatory.
Right.
It saw the black hole's intense X-rays.
Uh-huh.
But then they needed the James Webb Space Telescope with its super powerful infrared vision to confirm what they were seeing.
So it was real teamwork.
Totally, like a cosmic tag team.
I love that.
Yeah.
All right. Now, you mentioned something earlier about outflows from LID 568. What are those, and what do they tell us?
Imagine the exhaust from, like, a rocket engine, right?
Okay.
That's kind of what outflows are. Some of the matter falling into the black hole gets so hot that it gets blasted back out into space super fast.
Wow.
And what's crazy is that the size and speed of the outflows from LID 568 are telling us that, like, a huge chunk of its growth might have happened in one go, super fast.
One massive feeding frenzy.
Yeah, something like that.
Okay, so we've got this incredibly old black hole growing at an insane rate and potentially, like, rewriting astrophysics as we know it. What does all of this mean for our understanding of how these supermassive black holes form in the first place?
That's the million-dollar question, right? It really shines a light on this big debate about black hole seeds. Yeah, like the starting point for a black hole. Were they light seeds made from collapsed stars from the very early universe? Or heavy seeds formed from the collapse of giant gas clouds?
Interesting.
Well, LID 568, being so old and growing so fast, suggests that maybe both types of seeds are possible, and that those seeds can grow way faster than we ever thought.
So it's not just one answer. It's like both could be right.
Maybe. It's pretty wild.
It really is. It's like LID 568 is this, like, time capsule from the universe's crazy teenage years, showing us that things were even more chaotic and unpredictable back then. So what's, like, the biggest question for you that comes out of this discovery?
For me, it's like, how does blowing past the Eddington limit actually change the black hole itself and the stuff around it?
Right. Good question.
Like, does it mess with how the black hole interacts with its galaxy or affects star formation? And what does all that mean for, how galaxies evolve over time?
Man, so many questions. It seems like every time we learn something new about black holes, it just opens up a whole new can of worms.
Totally.
It really makes you wonder, right? Like, what else is out there? Are there even older, maybe even bigger, supermassive black holes lurking in the darkness, just waiting to be found? Ones that are even more mind-blowing than LID 568. Pretty crazy thought, and one I hope sticks with you long after we're done here.
I think it will.
I do too.